What is the most dangerous poison ever discovered? The answer lies in the invisible world of molecules, where the tiniest amounts can mean instant death. For millennia, life has evolved potent compounds for defense and predation, while humans have synthesized substances of staggering lethality. These poisons work not with brute force, but with subtlety, hijacking the very machinery of life at a cellular level. Today, we'll count down some of the deadliest substances known, exploring their origins and the terrifying power they wield. Let's proceed with caution and curiosity. We begin our exploration with botulinum toxin, a substance that commands both fear and fascination. It holds the title of the most acutely lethal toxin known to science, a distinction that underscores its immense power and potential danger. Produced by the bacterium Clostridium botulinum, a microscopic organism with macroscopic consequences, it's so potent that a few nanograms, an almost unfathomably small amount, can be fatal, highlighting the razor's edge between life and death at the molecular level. This bacterium thrives in oxygen-free environments, a condition that allows it to flourish and produce its deadly neurotoxin. Think improperly canned foods, where the lack of oxygen creates a perfect breeding ground, or deep wounds where oxygen is limited and the bacteria can multiply unchecked. The toxin is a protein with a specific and devastating target: nerve endings, the communication hubs of our nervous system. It works by blocking the release of acetylcholine, a crucial neurotransmitter, the chemical that tells muscles to contract, effectively silencing the signals that control movement. The result? Progressive paralysis, a gradual loss of muscle function that can have dire consequences. It often starts with blurred vision, as the muscles controlling eye movement are affected, and difficulty swallowing, a sign that the muscles in the throat are weakening. Ultimately, it can end with respiratory failure, as the muscles needed for breathing become paralyzed. A single gram, if dispersed into the atmosphere, could kill over 1 million people, a staggering figure that underscores the potential for mass casualties. This makes it a chilling candidate for biological warfare, a weapon of unimaginable destruction. Yet, in a twist of irony that highlights the complex relationship between science and society, tiny, controlled doses of botulinum toxin, known commercially as Botox, are used to treat a variety of medical conditions, offering relief from debilitating symptoms. And even smooth wrinkles, a testament to its ability to manipulate muscle function for cosmetic purposes. It's a stark reminder that the deadliest substances can also heal, depending on the dose and the context. This is only when understood and respected, handled with care and precision. The power of botulinum toxin is a testament to nature's ability both to create and to destroy. It highlights the delicate balance between peril and possibility that exists within the natural world. Its story is a warning and a marvel, a cautionary tale about the potential for harm and a celebration of scientific ingenuity, of the chemistry that shapes life and death, the intricate dance of molecules that determines our fate. Even the smallest molecule in the right configuration can tip the balance between health and disease. In the world of poisons, where danger lurks in the unseen, nothing is more potent than botulinum toxin. And nothing is more paradoxical, a substance that can both kill and cure, a true embodiment of the duality of nature. Next, we turn our attention to the castor bean plant, a seemingly innocuous plant with a hidden sinister side. It's the source of both widely used castor oil, a common ingredient in many products, and the deadly toxin ricin, a substance that has captured the attention of scientists and security agencies alike. Ricin is classified as a cytotoxin, a type of poison that targets cells directly. It works by attacking the very cells that sustain life, disrupting their essential functions and leading to their eventual demise. Extracted from castor bean waste, a byproduct of castor oil production, it's dangerously accessible, making it a potential threat in the wrong hands. And tragically, it has been used in assassinations and terror plots throughout history, a testament to its deadly effectiveness. Ricin disables ribosomes, the cell's protein factories, the very machinery responsible for building the proteins necessary for cellular function. It achieves this by snipping a single crucial bond in ribosomal RNA, effectively halting protein production and causing cell death, leading to widespread cellular destruction. Ingestion leads to severe gastrointestinal distress, causing vomiting, diarrhea, and internal bleeding. Meanwhile, inhalation attacks the lungs, causing respiratory failure and often proving fatally. There's no antidote currently available to counteract ricin's effects. Therefore, treatment is only supportive, focusing on managing symptoms, and survival depends heavily on the dose received and the speed of medical intervention. The castor bean's beauty hides its lethal potential, a stark contrast that underscores the plant's dangerous nature. It serves as a reminder that danger often comes in unassuming forms, lurking beneath a veneer of normalcy. Ricin's duality, benefit and harm, reflects nature's delicate balance, where even the most useful substances can possess a dark side. Its story is a warning to respect what we do not fully understand, and to approach potentially dangerous substances with caution and knowledge. Even the most familiar plants, those we encounter in our gardens and daily lives, can harbor deadly secrets, hidden dangers that we must be aware of. Ricin is a master of cellular sabotage, a potent reminder of the destructive power contained within the natural world. Its legacy is both infamous and instructive, a cautionary tale that highlights the importance of scientific understanding and responsible handling of dangerous materials. Handle with care, or not at all, a simple yet crucial message when dealing with the hidden dangers around us. Now we enter the realm of human-made poisons, a chilling testament to our capacity to manipulate the very building blocks of life for destructive purposes. VX nerve agent, a name that evokes fear and represents one of the most lethal substances known to humankind. Created as a chemical weapon during a dark period of scientific exploration driven by the demands of warfare, VX is an oily, odorless liquid, making it particularly insidious and difficult to detect. Its persistence is terrifying, lingering on surfaces for days, posing a prolonged threat to anyone exposed. Just a drop on the skin can be fatal. A minuscule amount is enough to disrupt the body's most vital functions. Inhalation is even deadlier, offering an almost immediate pathway for the toxin to wreak havoc on the nervous system. VX blocks acetylcholinesterase, a critical enzyme responsible for regulating nerve signals. By inhibiting this enzyme, VX prevents the clearing of nerve signals, leading to a catastrophic cascade of uncontrolled nerve activity. This causes muscles to contract uncontrollably, resulting in violent spasms and debilitating cramps. Victims experience convulsions, paralysis, their bodies overwhelmed by the relentless assault on their nervous system, and ultimately, death by suffocation, as the muscles responsible for breathing become paralyzed, leaving the victim unable to draw breath. Its efficiency and persistence, combined with its ease of production, make VX one of the most feared and unfortunately effective chemical weapons ever devised. A chilling example of scientific knowledge used for the purpose of mass destruction. International treaties now ban its production, a testament to the global recognition of its horrific potential. But the knowledge remains, etched in scientific literature and the minds of those who once pursued its creation. A sobering reminder of science's double-edged sword, capable of both incredible healing and unimaginable harm. VX is a product of ingenuity turned dark, a stark illustration of the dangers of unchecked scientific ambition. A warning about the ethical responsibilities of discovery, urging us to consider the potential consequences of our pursuits. Its existence is a testament, a grim reminder of the destructive paths that scientific progress can lead us down, to the destructive potential of chemistry, when wielded without conscience or consideration for human life. The line between creation and devastation, between scientific advancement and catastrophic misuse, is perilously thin. A boundary we must constantly strive to reinforce with ethical considerations and responsible oversight. VX is a silent, invisible killer, a threat that demands constant vigilance and unwavering commitment to its eradication. Its legacy is a call for vigilance and restraint, a reminder that the pursuit of knowledge must always be tempered by ethical responsibility. In the wrong hands, knowledge can be deadly, and the story of VX serves as a chilling example of this profound truth. Our journey now enters the atomic realm with polonium-210, a radioactive isotope infamous for its role in espionage assassinations. Polonium-210 emits alpha particles, harmless outside the body, but devastating if ingested or inhaled. Once inside, it bombards cells, shattering DNA and triggering cell death or cancer. A lethal dose is just micrograms, and symptoms, nausea, hair loss, immune collapse, appear only after irreversible damage is done. Detection is difficult. By the time poisoning is confirmed, it's often too late. The 2006 assassination of Alexander Litvinenko brought polonium-210's terrifying potential to light. This poison leverages the invisible power of nuclear decay, leaving a trail of radioactive contamination. Polonium-210 is a stark reminder. The most dangerous threats can be invisible, silent, and nearly impossible to trace. Its story is a warning about the misuse of scientific power. In the atomic age, even the smallest particles can be weapons, handled with the utmost caution. Cyanide, a name that echoes through history as a symbol of swift, certain death. This simple compound disrupts cellular respiration, preventing cells from using oxygen even when it's abundant. Found as a gas or crystalline salt, cyanide acts within seconds, causing dizziness, convulsions, and rapid respiratory failure. Its accessibility has made it a tool of industry, warfare, and countless poisonings. Cyanide blocks cytochrome C oxidase in mitochondria, halting energy production and causing cellular suffocation. The classic cherry red skin of victims is a grim hallmark. Antidotes exist but must be administered immediately. Time is everything. Cyanide's legacy is one of fear and fascination, a reminder of how quickly life can be extinguished. Its story is a lesson in the importance of vigilance and rapid response. Even the simplest molecules can be deadly. Beneath the waves, the pufferfish harbors Tetrodotoxin, one of nature's most formidable neurotoxins. Produced by symbiotic bacteria, TTX accumulates in the fish's organs, making it a deadly delicacy. Just 1 to 2 milligrams can kill an adult. Cooking does not destroy the toxin. TTX blocks sodium channels in nerves, silencing electrical signals and causing paralysis. Victims remain conscious as their muscles fail, often dying from respiratory paralysis. There's no antidote, only supportive care and hope that the body can outlast the toxin. Fugu chefs in Japan train for years to prepare the fish safely, a testament to the risk and allure. The pufferfish is a reminder that danger can be hidden in the most unlikely places. Tetrodotoxin is a marvel of natural defense and a warning to respect what we eat. Sometimes the most beautiful creatures are the most dangerous. Our final poison is strychnine, infamous for its violent, agonizing effects. Derived from the Strychnos nux vomica tree, strychnine blocks glycine receptors in the spinal cord, removing the brakes on nerve signals. The result: relentless, simultaneous muscle contractions and convulsions, with victims fully conscious and in excruciating pain. Even minor stimuli can trigger spasms so severe the body arches dramatically, a condition called opisthotonus. Death comes from respiratory failure or exhaustion, as the body can no longer breathe. Strychnine's bitter taste sometimes warns victims, but it has been used in countless poisonings and crime stories. Its use as a pesticide has declined, but its legacy endures as a symbol of nature's power to disrupt life's delicate balance. Strychnine is a masterclass in neurochemical chaos. Its story is a cautionary tale about the dangers lurking in the natural world. Even a small seed can unleash unimaginable suffering. Respect for these compounds is not optional, it's essential. As we conclude, we're left in awe of the diversity and potency of these poisons. From botulinum toxin to polonium-210, they reveal how easily life's balance can be tipped. These substances are not just threats. They're lessons in respect, responsibility, and the power of knowledge. Science gives us the tools to understand and, hopefully, to protect ourselves from such dangers. Stay curious, stay cautious, and remember, knowledge is the best antidote.